Chapter 6, Introduction to SQL, provides you with an overview of the SQL language. SQL stands for Structured Query Language, and it is the de facto standard language for creating and querying relational databases. Its usefulness actually extends beyond traditional relational databases, as you will see that SQL language are being used to query more contemporary database systems, including the new NoSQL databases. Therefore, understanding the general syntax and the logic of SQL language is very important to any information systems and business professionals who want to access and manage data resources for both transaction processing, application development, and sometimes business analytics. Over time, the SQL language has gone over many updates. However, the basics of SQL remain consistent throughout these standard updates. The updates mainly focused on providing new features to make SQL more useful in modern business scenarios such as e-commerce. There are also various versions of the SQL language developed by various database management system developers. For example, Oracle has its own version of SQL called PL SQL, and Microsoft SQL Server has its own version of SQL called TransSQL. Even though there are many versions out there, these versions all follow some standard syntax defined in the SQL Standard. Therefore, understanding one version of the SQL language would allow you to transfer your knowledge to other versions very easily. So you can consider SQL as kind of a universal language to work with relational databases. So in this lecture, we'll start by defining the key terms related to SQL and providing you with an overview of the history and the role of SQL in database application development and management. The first step in developing a database is to define its structure and convert our database design created in the logical design phase into the actual tables and relationships in the database software. That is achieved through the use of the data definition language, or DDL. We will discuss some of the most common DDL statements in this lecture so that you can create the structure of the database tables and then populate the tables with data. One key topic we'll discuss is how to establish referential integrity in SQL. As we discussed before, the rules of referential integrity was created to maintain data integrity during database use. SQL commands help us implement referential integrity through the definition of primary key and foreign key pairs. We'll then focus on writing single table queries using SQL commands. Here, we are going to introduce to you the most useful and commonly used select statement. For querying databases. In this chapter, we will work on querying a single table only, and then multiple table queries will be discussed in the next chapter. As you will see, the select statements are very versatile and relatively easy to write because their syntax is very similar to the English language. Finally, we will discuss the use of views, which are temporary database tables that can be used to simplify and assist querying data. You will also get some hands-on experience with SQL in this module by executing SQL commands directly in the database management system. To enable relational databases, IBM Research Lab in San Jose developed the SQL language, which stands for Structured Query Language, in the late 70s. The language was very well received due to its ease of use and versatility. As a result, it became a standard approved by ANSI and ISO in the late 80s. With the popularity of relational database management systems in business, today SQL is the most widely used language for relational database management systems. In a relational database, data are stored in tables called relations, and the relationships between the tables are represented using common values in the primary and the foreign key fields of tables. This standard structure of relational database has made database development easy and flexible. Therefore, relational database is by far the most widely used database structure in business. Although extensions of the relational structure have been created for various modern database applications, SQL language remains the de facto language for dealing with all kinds of database systems today. This slide provides you with a brief history of SQL. As with any information technology, the SQL Standard continues to be updated. Since it is a relatively mature technology and standard, there has been little updates to SQL in the recent years. The SQL Standard can be applied to databases both small and large, ranging from databases on mobile devices and those that run on supercomputers. In this lecture, we will illustrate SQL using the Oracle SQL syntax most of the time, due to Oracle's dominant market share in the database market. As I mentioned before, since SQL is an ANSI standard, the statements should work in most database systems and other systems with very minor modifications. The SQL standard was created for a number of purposes. First, the standard specifies the syntax of data definition and manipulation language, so that developers only need to understand one query language that can be applied to databases developed using different technologies and by different vendors. Second, the standards define the way in which relational databases should be designed, accessed, and secured, creating an industry standard for high-quality data management environments. Third, the standards increase the portability of applications across different database platforms. Different database vendors will develop their own software products to comply with the standards. Two levels of standards, the minimal or level 1 and complete or level 2 standards, are defined so that different vendors can choose suitable degrees of adoption of the standards in their products. This flexibility not only provides a basic cross-platform solution to database development, but also offers database vendors some flexibility to create unique features that would differentiate their products from other products on the market. Finally, the standards were designed to allow future enhancements as technologies change and new user scenarios arise. The standard SQL language provides a number of benefits to advancing and popularizing the use of relational databases in business. It reduces training costs for IT professionals who often have to deal with ever-changing technologies. The standard language can work with any type of database applications across multiple platforms, reducing the learning curve for developers who are moving from one technology platform or application to another. Second, due to the reduced learning curve, it helps increase the productivity of the developers, and at the same time, the portability and the longevity of applications. Companies often spend millions upgrading software products that they invest millions to develop at the first place when new technologies come along. With the standard query language, as long as the software applications adhere to the SQL standards, the application will require minimal upgrades when moved to a new technology platform, and that extends the useful lifespan of the application. From the business perspective, companies are less dependent on one vendor for their database applications. Moving systems to a platform by a different vendor has become easier and less costly with the standardized SQL language. Finally, in today's interconnected world, cross-system communication is a key feature of many e-commerce and analytics applications. The standard SQL language helps enable cross-system communications between different types of computer systems. So these are the key benefits of a standard relational language such as SQL. But at the same time, we have to realize that the standard language can also stifle creativity and innovation in the database field. Since its inception in the 80s, little has changed in SQL language. This may suggest superiority of the SQL language over alternatives, but can also mean that missed opportunities for innovation in this area. Nevertheless, SQL seems to be sufficient in handling all major types of business scenarios at this point. With the support of a very large vendor and user community, this language will likely continue to be the industry standard for a very long time. Therefore, it is really important for any information systems and sometimes business professionals to understand the SQL language in order to deal with data access and data management. Before we get into the syntax of SQL, we need to understand the SQL environment. To many users today, accessing database is intuitive and transparent thanks to the easy-to-use user interfaces such as the web browser. However, for information systems professionals, it is important to understand what's under the hood in the SQL environment. A SQL-based relational database environment involves a user interface such as the web browser or an application interface or a management interface, a set of database tables where the data reside, and a relational database management system or RDBMS that facilitates the communication between users and databases. The RDBMS interprets the SQL language to process a wide range of operations, such as create tables, insert data, update data, query tables, and so on. There are a few key terminologies that are used to describe the SQL environment. First, the terminology catalog. So a catalog is defined as a set of schemas that constitute the description of a database. So as you can see, to understand what a catalog is, you first need to understand what a schema is. And in the database context, a schema is a collection of related objects in a database. For example, customer table, orders table, description of the user rights to various elements of the customer and orders table, and the procedures that will be executed when the tables are accessed. These are all different objects in a schema. Different schemas may be created by different users, or for different database applications or business functions. When you put all these schemas together, it becomes a catalog, which is a logical container of multiple database components that are related to each other. One of the schemas in the catalog is called information schema, which is a roadmap of the catalog that describes the different components that are included in this catalog. Users or developers issue SQL commands to interact with the components of a catalog and/or schema through the database management system. SQL commands can be classified into three major types, and they are data definition language or DDL, data manipulation language or DML, and the data control language or DCL. So data definition language are commands used to create, alter, and drop tables, views, and indexes. They are often used to define database structure, implement business rules, and maintain data integrity through enforcing referential integrity rules. We are going to go over some of the most important DDL commands in this lecture. Data manipulation language, or DML, includes commands used to update, insert, modify, and query data in a database. Therefore, they are considered core commands of SQL, used by end users and application programs to manipulate data in a database. For example, when an online transaction occurs, from the database perspective, it embodies a series of insert, update, and delete actions triggered by the SQL commands. In analytics, data are queried and presented to users in many useful formats for decision support. In this lecture, we are also going to go over some of the key DML commands, including the most useful command of all, the select statement. Finally, DCL, which stands for Data Control Language, includes commands often used by database administrators to control the access, backup, and security of the database. These commands are used to define user privileges for accessing data, for backing up data, and for enforcing security policies. We will delve into these commands in a later module that deals with data and database administration. This diagram offers a simplified schematic of a typical SQL environment. As you can see, the user often interacts with application programs such as an online shopping app, a transaction processing system, or an analytics software that would communicate with the DBMS by issuing SQL commands. The DBMS interprets the SQL commands and performs the actions to various database components. In this diagram, there are two catalogs. One is the development catalog, and the other is the production catalog. They simply define two separate physical, sometimes logical, partitions of the database environment, one for developers and another for actual users of the databases. Within each catalog, there are various database components, including the data tables, various user schemas that may include user views, procedures, and triggers, and the information schema that provides the metadata for all these components in the catalogs. This slide describes the stages in which various SQL languages are being used. For example, data definition language, or DDL, is used during the physical database design and maintenance phases. During the physical database design, the developer uses DDL to define database structure, data types for various fields, and set integrity controls to avoid any future data inconsistency. As data and table definitions may change as business scenarios change in the future, during the maintenance phase, database developers will then modify database structures using DDL again. Therefore, DDL is being used in both physical database design phase and the maintenance phase. DML is mostly used during the database implementation phase. During the implementation phase, database updates and queries will be triggered by the user and applications. In most cases, DML commands are embedded into the application program that interacts with the DBMS to perform various updates and query actions. Finally, DCL, or the Data Control Language, is used in both implementation and maintenance phases. That's because to control user and application access to data, various user privileges and access rules must be defined during the implementation phase as part of the functionality of the database application. In addition, as database control is an ongoing activity, as users and business scenarios change, DCL commands are used during the maintenance phase to continuously maintain the integrity and security of the database.